All right, we are resumed. So I guess I'm recording for the benefit of who? Ellie? Is that it? Yeah. Yeah. All right. So today we are the good news is that this should be kind of a thing from the past. So we are going to be, that's what, the 13th. Um, so we are adding and subtracting rational expressions. We've already done multiplying and dividing. I doubt you remember it specifically, but we did it a month ago or at least. Those were the ones where we factored and then canceled stuff out. This is significantly more difficult than that, just because the the canceling doesn't work quite the same way. So, anyways, these are adding and subtracting, and specifically rational expressions. I guess I'm making this recording for Cooper also, since he'll probably go back and watch it since he's working on his quiz. So there you go, Coop. Okay. So I whipped up some examples for you just to get us cooking. So I'm going to pick these in no particular order. I have 5 of them. So we have 6 over x plus 3 over x plus 1. I just like to ask questions like this just to feed my curiosity. Does anyone by chance remember what makes this difficult? So going all the way back to like 4th or 5th grade, um, so there was a point in your life where addition was easier and subtraction, like addition and subtraction were like the easy ones. And then times came in like 4th grade and everyone was like, ooh, or multiplying. So there was a point in your life where plus and minus were easy and times and divide were hard. And then something happens around high school where it gets flipped. It probably happens sooner than that. Why is adding with fractions so much harder than multiplying? Because you have to have a common denominator. And if we have any lack of success over the next few days on this, that will be the reason. Nothing that we do after the common denominator, I don't think is hard, but trying to understand the common denominator is the hard part. So, and I chose this kind of on purpose because I want to see what you say. What do you think the common denominator is? That's what I would have said if I were in your seat. I would have said that because I feel like a common denominator should have some of everybody, right? And if I say x plus 1, it has x plus 1, but it also has an x in it, right? It doesn't work that way. And the thing about it and why it doesn't work that way is that this x right here, the one I'm pointing at, he's not an out free factor x. He's part of something. He's wrapped up in an addition problem. So some of the words you hear, they might come back to you from the past, but the bottom line is x plus 1 is not something that you can go cherry pick parts of it out. You cannot say that that x that I'm pointing at with the red arrow covers the other x. The other x is a factor. The one on the left is a factor. The one on the right is part of an addition problem. They're not the same. So believe it or not, the least common denominator between these two fractions is x times x plus 1. Again, the x that's a part of the plus 1, he doesn't get to do double duty. He doesn't get to be part of an addition problem and then also be called a factor. It's the hardest part of this is convincing people of that. So I realize that there's a decent chance that that probably doesn't make a whole lot of sense, but it'll just be one of those things that eventually we just kind of get stuck. But that is the least common denominator. So once we figure out what the LCD is, do you remember what the next step is? Like if I were a 4th grader or a 5th grader and I were just learning fractions and my teacher told me that, the common denominator was like 12. I was going to add 2 fractions and they had a common denominator of 12. And if the bottom of a fraction was like a 3, what would I do to turn it into a 12? I'd multiply it by whatever it needs. In that case, 4. Correct. Correct. And so what happens here is we wind up just looking at each fraction and asking ourselves, Why don't you have the common, not like in a challenging way, like what's wrong with you, but the question is, what are you missing? Why don't you have the common denominator? What's keeping you from having this as your bottom? And whatever the answer to that question is what we multiply by. So the first fraction, you look at it and you say it has x on the bottom, so it has part of the common denominator, but it doesn't have the x plus 1. So we take the 6 and we multiply it by x plus 1. And by the way, if I were to stop right there, that is so illegal. That would make me the worst teacher in the world. I need you to understand that I'm not just multiplying 6 by x plus 1. I'm also multiplying the bottom by x plus 1. We will stop showing that like soon, nowish, because we understand what the mission is. Like the mission is we know the bottom is changing, but our focus is the top. So we are multiplying. Whenever I say we're going to multiply the top of it by this, the implication is that we're also multiplying the bottom. We just don't want to show it every time. How about this second fraction? What's missing from his bottom? Right. And it's weird to say that because, again, if you're stuck on what I said a while ago, you're like, BS, it has an X right there. Not the same. So we're going to need to take the top, the 3, and we're going to need to multiply it by X. And then we're going to take the bottom and we're going to multiply it by X. At this point in time, it becomes a pretty basic algebra problem. It's all just like a collection of basic skills at this point. So I'm going to take my top and I'm going to work it out. So it's going to be 6x plus 6 plus 3x over x times x plus 1. The thing about fractions is once you make their bottoms the same, then you can freely add or subtract the tops, as long as you just put the bottom back as to what that sameness is. What do we get on the top? 9x plus 6. And the bottom is just x times x plus 1. And some problems are more exciting than others. This one, got to be honest, is pretty lame. That's the end of the problem. The temptation is always for people to ask questions like this. And we'll see. I'm curious to see how you answer this question. Someone who's just learning this would look at these x's and say, can't I cancel those out? And you remember this, hopefully, what keeps us from being able to say, do it?
It's connected.
That's it. The X on top is connected to an addition problem. Like it's part of an addition problem. It is not a factor. And that's the hardest thing to understand is like, what's the difference between a factor and an addend? An addend is part of an addition problem, a factor. And is it a factor with the 9? Yes, I get that. Could I factor the top by pulling out a 3? Yes, I get that. But at the end of the day, there's actually nothing in here that's the same from the top to the bottom. What's up?
So before we distribute the 6, we wouldn't be able to cancel the x plus 1s either.
It's a funny thing that you'd ask that, and you'll laugh at yourself when I tell you why not, because then it would be literally right back where you started. Do you see that? I mean, you may not think it's funny the way I do, but like I assume you're referring back here to these x plus 1s. And if you think about it, it's like,
No, I'm saying when you add those together, you just put in 6.
no. So let me show it in its raw form. Okay, so it's not as comical as I thought it was. So if I showed it, and I wondered if I should show this step or not, and I conversationed myself out of it, the top would look like this. Correct? Is this what you're asking me about?
Yeah.
And again, as hard as this is to understand, is that a factor? Nope. It's part of an addition problem. And I'll just say that that'll become like our battle cry for the next few days is if it's part of an addition problem, you can't cherry pick it out. Those look so delicious and tempting, right? But no, this x plus 1 is like, whoa, you stay off, leave me alone. I'm part of a bigger thing. I'm part of an addition problem. I am off limits. It's the exact same reason why these x's that I'm circling in red are off limits because they're parts of the one on top is part of an addition problem. Got it? You with me there, Belair? What's the matter?
The cat thing.
Is that what you've been thinking about for a while?
Is that where you have the cat?
Very much so.
Like every time you do this, it's like,
The cat dies or whatever?
Yeah, you want to see the
I
cat?
think
Yeah.
you blow it up.
Yeah, I don't want you guys to be thinking about this. I mean, I can change my background for the next few days if you'd like. It's called Cancel Kitty, and I got to figure out where he is. I know, right? Not very imaginative, but Cancel Kitty, where'd you go? There he is. Hello, Kitty. Hello, Ghetto. So yeah, that's him. Yeah, and that's I guess what I try to. Mrs. Eklund discovered this on the internet a few years ago, and we both fell in love with it. So it became kind of a jokey thing that we would post every once in a while. But yeah, I mean, the point is, like, as tempting as it is, why can't I cancel those x squareds? Because they're parts of addition problems. So subtraction is the same as addition. Same rules apply. So you just don't go there, or this little kitty dies. Okay. Or a kitty just like him. Someone just as cute. Yes, this is the thing with the kitties.
Yeah, so I was thinking about the whole thing.
Ringing some bells? Good. So anyways, if I wanted to make this problem that we just worked on more exciting, and I'm just going to sidetrack myself a little bit here. If I had wanted this to be a more exciting problem, I would have engineered it so that this would be, say, like a 9. And if you don't know why that matters, we'll take a look at this. Imagine it said 9x plus 9 over x times x plus 1. What could I pull out of the top? Correct. And if I do that, then I pull out the 9 and I'm left with x plus 1. And now, hopefully this might unconfuse you a little bit. Why now can I cancel out those x plus 1s?
They're not part of it.
Because they're not parts of addition problems. They're parts of multiplication problems. They are now what we call factors. Factors are cancelable. Addends are not. So you could have put a little extra flavor in there, but I didn't. It's pretty boring. And so I would stop right here. Could I factor the top of this just out of curiosity? I could, but you might remember me saying before, it serves no purpose because you get 3 times x plus what? 3 times 3x plus 2. And then when you search around for that having any like purpose, there's no 3's to cancel with. There's no 3x plus 2's on the bottom. So the rule is like factor if it serves a purpose, but you don't have to if it isn't going to serve a purpose. Good. All right, let's muscle through some more. Hope that made some iota of sense to you. How about this one? Thoughts?
Could you just multiply the right with 2x1?
Yeah, listen, before we go anywhere, the first thing that because you guys are such good students, I need to just say this. When I say like, what do we do or your thoughts, your thought needs to come out as let's find the least common denominator. So that's what I'm going to be implying every time I say that. I just don't want to even move on or have any sort of conversation until you tell me what that is. So I'm going to write this down, and that just has to be our conditioned first thought. So tell me, what is the least common denominator?
4x.
I need a 4. I need an x, and I need a y squared. Perfect. So it turns out that the first denominator, you saw this back in like 5th grade. If your teacher said do like 3/8 minus 1/4, sometimes one of the fractions already has the common denominator, right? So we don't have to change the first one at all. So we can just leave him alone. But going back to Brady's question, what do we multiply the second fraction by?
2x.
Right, exactly what we need. No parentheses like plus or minus e parentheses this time because these are called monomials. These should be our favorites. That's not always the case. So we're going to multiply by 2 because we have to, and we're going to multiply by x because we have to, and another y because we have to, because we're building something. And then we get, and I'm just going to skip this. I don't think I need to show like I did last time. I'm just going to show 5 minus 6xy all over what? See anything that you can cancel?
No.
Good. The quicker you condition yourself to just say no, the better off the next few days for us will be. We are not going to fall into temptation. We're not going to try to cancel those X's or because they're part of something else. So That was a good one there. All right, let's do another one. How about 3x over x plus 2 minus 2 over x minus 2? Now, 15 or 20 minutes ago, if I had said what's the least common denominator, you guys would have said something crazy like x minus 4 or some x minus, I don't know what you would have said. We know better now, I think. What is the least common denominator?
Is X squared minus.
Yeah, you caught me off guard by actually multiplying it out there. But yes, the least common denominator is I need one of these and I need one of these. And honestly, they're really, as awesome and rad as that was, there's really no benefit to multiplying it out because we're just going to probably have to demultiply it anyways just to see what we want to see. But that was pretty cool. So let's lead it looking like that. Does everyone understand why those two don't overlap? Make more sense than it maybe did the first time. They're not like each other at all. They both have X's, but they're not like, you can't do double duty. So what do we do to the first fraction?
Y minus minus
Yep. What do we do to the second fraction?
2.
Yep. And this time I am going to show what it would look like. So it's going to be this. It's going to be 3x times x minus 2 minus 2 times x plus 2. And it's all over x plus 2, x minus 2. The reason I wanted to show this one like this is so that we don't do anything crazy like an 8th grader or 9th grader would do. What do you notice that would be a hot spot for mistakes? Well, canceling would be a big mistake, right? Nothing is canceling here at all. But what do you see some basic skillsy stuff on the top that would be easy to miss? Yeah. And maybe you just you've outgrown it. Like you've been in enough classes with me that you just don't do this, but this is a -2. So the most common mistake I expect to see, I hope I don't see it at all, but the most common what I would expect would be this. Someone would put 3x squared minus 6x minus 2x plus 4. And that's how quick it can happen. And if that looks completely stupid to you, then we've done a great job together as a team of teaching you math, you learning math. What did I do wrong? Yeah, 4 should be a dang minus, right? Because distribution. So this minus that hides in the middle of problems, I'm going to circle it in purple for you. That minus right there this could be a killer because it's like a distributor. And so just be careful, I guess. So we do wind up with -4. And then when we clean all this up, we get 3x squared minus 8x minus 4. And we put that all over x plus 2, x minus 2. What would be the only avenue through which we could have more work to do on this problem? What could happen that would make this problem take longer if the top was factorable? And it's very useful to know the factoring test in a case like this, just to look at it and go, God, I wonder if I can factor the top. And there is a test. Any of you by chance remember the factoring test?
Yeah, I missed one for you.
No, so that came out wrong. Does anyone remember like the test that I can perform on a quadratic trinomial to see if it's factorable? Here it is. Pretty dope trick.
In the back.
Yeah, you take the 3 and the -4 and you multiply them together. What do you get? And then you ask yourself, are there numbers in the known universe that can multiply to make -12 and add to make -8?
Yes. Or no, there's not.
I was going to say, I'll give you $1 if you could tell me what they are. Because they both there has to be one positive, one negative, right? And you can't do that. Like a +2 and a -6, a +1 and a -12. If you can't find numbers that multiply to make the end product, the outer product, and add to make the middle, then it's not factorable, and this problem is